Entropy, represented by S, is a measure of randomness or disorder of the system. You can actually calculate its value, so even elements have entropy. Standard entropy of hydrogen, for example, is 131 joules per Kelvin per mole. Lithium, a solid, on the other hand, is 29 joules per Kelvin per mole. Now, an entropy change is represented by delta S, usually for a reaction, products minus reactants. If it's positive, it indicates there is increase in entropy, which nature favors that. So, for example, if you take liquid water and evaporate it into steam, delta S, the change in entropy is positive 119 joules per Kelvin per mole. So the positive is indication of increase in entropy of the system. A negative delta S, on the other hand, indicates there is a decrease. If you take ammonia, a gas, hydrogen chloride, a gas, and mix them and you produce solid of ammonium chloride, delta S rather goes down and there is a negative value for that. So this indicates that this solid is more ordered compared to the gases to begin with. Now, how do you predict if a reaction is positive delta S or negative? The most important factor is to determine if you're increasing number of gases or decreasing number of gases. So this is the most important indication to guesstimate if the reaction is delta S positive or negative. Let's look at some examples. The first example, you see one molecule of gas for C2H4 plus another, so you have 2 moles of gases on the reactant, and it's becoming only 1 gas on the product side. So this is indications that delta S is becoming negative. Delta S is minus, it rather goes down. There is a decrease in entropy. The second example, you have a solid that sublimes into another solid and a gas. As soon as you produce this mole of gas on the product side, this is indication that delta S is increasing and there is a positive value if you calculate it. So we can guess what is the sign of delta S. The third example, you see fluorine, a gas, hydrogen, a gas, 2 moles of gaseous on this side, and it gives you 2 moles of gas on the other side. So this is indication that delta S is most probably equal to 0. There is no increase or decrease in order of the system. The fourth example, if you look at dry ice subliming into a gas, you're producing definitely a gaseous particle. Delta S is increasing and it's a positive value. And the last example, I have aqueous, this is supposed to be hydrogen peroxide, is becoming liquid water and gaseous oxygen. As soon as I see this gas on the product side, I know delta S is increasing because I'm producing more particles of gases on the product side. Now let's just calculate it instead of prediction. The value of delta S can be calculated by sum of, this is a symbol for the sum of entropy of products minus sum of entropy of reactants. They usually give us the data too, so I have here in this reaction nitrogen added to 3 molecules of hydrogen to give me 2 molecules of ammonia. So delta S for this reaction is simply equal to the products minus reactants. So this are reactants, this is my product. I have 2 ammonia, so I sum them up. Each ammonia is 193. So this is my product minus my reactants. On the reactant side, I have 1 nitrogen, which is 192, plus 3 particles of hydrogen. Each hydrogen is 131. So 3 times 131. And when you do this, you will get minus 199 joules per Kelvin per mole. You can also check to see if the minus is meaningful or not. Let's just go back to the equation. You see on the reactant side you have 4 particles of gases versus on the product which you only have 2 particles or 2 moles of that. Therefore delta S should go down and it should be negative, and we just calculated that and it's negative. So you can also double check your understanding with calculations. One other problem to do, this is C2H6 that is breaking into C2H2 and releasing also 2 hydrogens. Calculate delta S. So delta S then again is sum of S of products minus sum of S of reactants, and we simply plug it in and try not to make mistakes. These are my products. I have C2H2. So C2H2 is 201. Plus 2 hydrogen, each hydrogen is 131, minus my reactant, which is simply C2H6 minus 230. If I didn't make any mistake, this becomes positive 233. Then again, joules per Kelvin per mole. Write your units until it becomes friendly. Now let's see if it makes sense that it's positive. You see on the reactant you have 1 particle versus on the product which you have 3 moles or 3 particles of gases. So definitely delta S is increasing, delta S should be positive, and we just calculated that it's positive.